Okay, now we're moving to part B for our quarter cylinder problem, where it wants us to find the del operator across F. So just here's what our figure looks like. We're given this F, and this part is just basically number crunching here. So I took this del cross F for cylindrical coordinates from the cheat sheet that I attached at the bottom here. Sorry, this guy right here. Just for reference, if you want to try to solve that part out yourself, please do. For the sake of time, we're just going to kind of go through it this way and show the components here. You can always use this method to try to check and make sure that your actual answer is correct. So we have an A phi component, right? So let's circle. So we have all these A phis here. And then we have an AR component. So we have AR here, right? There, here, but our AZ is equal to 0. So this AZ is equal to 0. So we're going to cancel those. So this will go to 0. This will go to 0. And yeah, there we go. Now we're going to look a little bit closer here. And we're going to notice that we have the derivative with respect to z for A phi and the derivative with respect to z for AR. But if we look at these expressions, there are no z terms in them, which means that this is basically the derivative of a constant. Both of these are, which means that they will be equal to 0. So by derivative of a constant, I mean, do you ever do z with like respect to 1 or 2 or just a number? It's going to be equal to 0. So we are treating this expression because there's no z terms as a constant. Okay, so the only piece that we have left here, so these cancel, right? So the only piece that we have left are the ones in the z hat direction here. Sorry, this is a little difficult to see. That's what happens when you get your cheat sheets online. Okay, so we're going to rewrite this out. So we're going to have the partial, and there is an r inside of this partial derivative for cylindrical. So just kind of be very careful with that. R squared cosine of phi. So we're putting our AR term into, or sorry, A phi term into here, and then minus derivative with respect to r sine of phi, and that is with respect to phi. Okay, so let's go ahead and do the operation here. So we have our cube cosine of phi respect to r. I'm actually going to do it this way to kind of show you which terms we care about. So this is a constant, treating cosine of phi as a constant. Sine of phi divided by 5r. Okay, so we are going to end up with, n 1 over r, and this is in the z hat direction. Okay, so we're going to end up with 1 over r times 3r squared cosine phi minus 5r cosine of phi, and z hat direction, so we're going to get 3r cosine of phi minus 5 cosine of phi, so 3r minus 5 cosine of phi. We're just going to group these. Z hat is equal to our gradient cross f, I believe was our expression. Our vector is called f. Yes. Okay, so this is our final solution here. And we're going to take this and we're going to plug it into part 2 of our expression. So we just basically did a lot of number crunching here. And we found our curl. So this is what this part is. This is our curl. Okay.